Hi everyone, welcome to the video today. As I'm clearing my throat, sorry about that. Today we're going to look at maximum and minimum problems. And so when there's sort of worded questions usually where you're asked for a particular function or a particular situation, you're asked to find what's the maximum dollar value or the maximum area or the maximum height or something like that. So you're asked to find something big or small, or what's the minimum, what's the smallest, blah, 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 blah. And so a couple of tips before we get started. Firstly, really always helpful to draw a diagram. Good to see what's going on. You can see relationships better when you draw a diagram to try and figure out sort of what's happening there. Okay. Second tip is to try to find a function in terms of one variable only. Quite often what you'll have is you'll have more than one variable, like you might have in a rectangle with length and width, or you might have a radius and an angle theta or something like that, and you'll end up with two variables in there. What you need to do is try to find another relationship to substitute in so that you've only got one variable. So that's the sort of second thing to try to do. From there, find stationary points. We're trying to find maximums and minimums. Quite often they come from the turning points, the maximum turning point or a minimum turning point. Not always though. Test their nature, check to see whether they're maximums or minimum. Reject any unrealistic solutions. So if you're getting time has to be, usually it's greater than 0. So if you're getting time's equal to -2 seconds, quite often that's an unrealistic thing. You can't have negative time. Or find the length of a square and you get -10. Well, you can't have a square with -10 length. So just check that everything is realistic. And lastly, check the endpoints. You could get an absolute maximum or absolute minimum at the end, at the start or finish of the function, not necessarily from a maximum or minimum. So you need to check all of these things in these problems. So let's just go to an example and have a look at one. Okay, so a window maker is creating a window with a rectangle joined to a semicircle. If she has 3 meters of framing, what is the maximum area she can create and what are the dimensions? Okay, so again, firstly, just a diagram is worth so much. Okay, so we've got a rectangle like this and it's joined to a semicircle. It's not the greatest picture in the world, but you sort of get the idea. So rectangle joined to a semicircle, and let's just have a sort of like label some things. So what are the important things here? Like, because it's a rectangle, we want to know what this sort of, that height, let's call that H. And we've also got this this length here across here. I'm just going to call it W though for width instead of length, because length often, like with L's, it doesn't work well in algebra, so it looks a bit messy. The other key part here is that because we've got a circle here, circles are defined by their radius or diameter. But in this case, we already know that there, so let's call that the radius of the circle, that's going to be half of W, okay? So we definitely don't want to bring in another variable. We've already got 2 variables in this question so far. So we don't want to bring in a third one. So what we'll just remember is that radius will always be half of W, okay? Because that width defines the size of the circle. So we're not going to define that. We'll just leave that out. But let's have a look at it. So firstly, we want to maximize the area. We've also, I haven't forgotten about it, we've also got this piece of information that we'll use in a second. But we'll just start writing down what we know, okay? So firstly, let's have a look at the area. Now the area will be equal to width times the height, so WH, width times the height. So that's that area there. Okay, but I also need to do the circle. So so it'll be half of pi r squared. Area is pi r squared, so that's half pi. The radius here is half of W. Remember I said to remember that, so I'll call that W over 2. That's the radius, and that's squared. So half pi r squared. So there's a formula for the area of this window shape. Again, you'll notice that it's in terms of W and H. We've got 2 variables in here, so we need another piece of information to try to get a function that only has 1 variable in it. So let's now bring in this third piece of information that we haven't looked at yet, where we've got the perimeter of the frame. So that green, I'll put it in green so you can sort of see it. The perimeter of our window is equal to, all right, so I'll think there'll be two H's in there because we've got this side and this side, so two H's plus W plus that circular bit. How long is that circular bit? Remember the perimeter or circumference of a circle is equal to 2 pi r, also known as pi d, okay? So that times the diameter, and we've only got half of that today. So 2 pi r divided by 2 is pi times the radius, because we're going to get half. I'll write it down just so that you can sort of see it. So it's half of 2 pi, and what is my radius? My radius is W over 2. Okay, so there is I guess a formula for the perimeter. And so what we can do, now we've got these sort of two formulas, what we could do is we could sort of extract something from here where we could either get rid of the W or the H in this equation. That top equation is the one we want. That's the area. We were trying to maximize it. So that's the function that we're interested in. So we want to replace either W or H. Now, my gut feeling here is that we want to replace the H here, okay? The reason I want to choose that, because if I replace the W, there's two places that the W occurs in there, and I have to replace things twice. So I'm going to prefer to find height. And so what I can do is like find H here. If I can solve for H here, then I'll get something. Now, the other thing that I haven't done yet is put the perimeter equal to 3, and so that 3 is the perimeter, so 3 is equal to all of that. Let's see if we can solve for H here, okay? It's a little bit messy. We've got some pi's and got some other things, but we'll sort of work our way through. So let's have a look at it. So we've got 3 is equal to, I'll just simplify this, 2H plus W plus, let's simplify that. We've got a half and we've got a 2, so that will cancel out with that half and that 2. And so what we've got pi W over 2 in the back end there. Just make sure I've got everything right there. 2 half, yep, that cancels out, perfect. And so therefore, what I'm going to try to remember, I'm going to solve for H. So H is equal to, I'll leave the H on the right hand side, and I'll drag everything over to the left hand side. So that's equal to 3 take away W, moving that W across, minus pi W over 2, and we're going to divide that whole thing by 2 to get rid of that 2 there, okay? And so that's my H, and that looks pretty messy at the moment. I don't really like that a lot, pretty gross. So let's just do a couple of things with this. What can we do with this? How about I multiply the top line and the bottom line by 2? Let's do that. So multiply effectively times 2 over 2. And so what we'll get is 6 minus 2W minus pi W. That multiplies everything on the top line by 2, multiply things on the bottom line by 2, and we'll just get 4. And so that's actually a fair bit nicer there. So let's leave it like that. Okay, so now that we've got a H, what we can do is put it into our first equation, which has our area, and it's going to be a bit messy, that's okay. And so what I want to do now, I'll just sort of come up here because I'm trying to be able to see what I'm doing. And so area is equal to W times H, so that's W times by H, which is 6 minus 2W minus pi W over 4. And then I've lost it. There it is, plus half. And I could probably simplify this. Hang on, I should actually look at this junk here. How can I simplify that? Well, that's W squared over 4, half of that. So you're going to have over 8. So it's going to be pi W squared over 8. Okay, and that's my area. So now I have a formula for the area in terms of only W. I've only got one W in there. Sorry, only one variable in there, which is perfect. Okay, I'm really happy with that. I'm just going to expand it out because in a second I know I'm going to find the derivative of this. Okay, so that's going to be, and I might bring that 4 out the front as well. So I might actually take it out the front like that. It's actually probably a little bit easier to look at. And so that'll be 6W over 4 minus 2W squared over 4 minus pi w squared over 4. Check that I haven't made any mistakes. That looks good to me. Plus pi w squared over 8. All right, fantastic. So there's my function for area. Looks a bit messy, and it is. There's some horrible fractions in there. Apologies for that, but that's just the way it is. So I've got my area. I'll just write area there, and I'll put a box around it because that's my sort of the function that I'm happy with. And I could, I was wondering then if I could combine this and this, but one's got a pi and one doesn't. So you got that pi there. Oh, I've just noticed that I've got that and that, both pi w squareds. And so I could do some work. I can actually. So I'll make that 3w over 2 minus, oh, gee, there's all sorts of simplification I can be doing here. Don't mind me. And then those two things are actually equal to each other, I've just noticed. Minus pi w squared. I'm just checking that I've done everything right because I'm surprised that they have cancelled out. So that will be minus 2 pi w squared over 8 plus that. So it will be actually minus pi w squared over 8. Let me just check I've done that right, because what I've essentially done, let's get a different color. If I times that by 2, times that by 2, so they've got 8 on the bottom line. Then you've got negative 2 pi w squared plus pi w squared. Yep, that's right. So that is a much better formula for the area. Well done, me. So that one is our key formula. All right, so we've got this equation for the area. What we want to do now is we want to have a look. We could go and sketch the graph of this, right? Let's assume that we haven't got calculator in this question, because we want to sort of see how we go about doing this if we don't have a calculator. You could, so at the moment, you could go and sketch this function on CAS or on anything really and have a look at it and see where is that area going to be a maximum. Remember, this question asks where is it a maximum? So you could go and have a look at that, find the value of D, you could analyze the graph and see where the maximum point is and figure that out. But we haven't got that, so let's just play on. I just want to show you how calculus works here, right? So let's have a look at dA dW, right? So the derivative with respect to W. This will help us find any turning points for this particular function. So 3w over 2, that just goes to 3 over 2, minus w squared over 2, so the 2 comes down the front, so minus 2w over 2, and that 2 goes down to 1. So those things will cancel out in a second. We'll clean that up in a bit. And then minus 2 pi w over 8. So that, again, that 2 comes down the front, and that 8 just sort of sits there because it's just a constant sitting out the front. And that's it. Let's just clean it up. So it's 3 over 2. That 2 and that 2 just cancel out, so that's minus w. And that 2 will just cancel out that with 4, and so it will be minus pi w over 4. So there is my derivative with respect to w. Okay. All right. So now when you want to solve, to find turning points, there's a lot to these questions, aren't there? Isn't there? Turning points when dA dW equals 0. So let's have a look. So we're going to have 3 over 2 minus w minus pi w over 4 equals 0. It will give us our turning points. Because we've got w in 2 places, let's actually factorize that out. Should I just do this quick or do it slow so that everyone can see what I'm doing? I'll do it slow. All right, so let's move that 3 over 2 to the other side. And so we've got negative w minus pi w over 4 equals negative 3 over 2. Moving that 3 over 2 to that side. I'm just going to go across. Sorry for going across, but I'm just going to run out of space otherwise. And let's take w out. W negative 1 minus pi on 4 equals negative 3 over 2. Therefore, w equals, and we'll divide through. We're going to have negative 3 over 2. And we're going to divide by that to get rid of it. And so if we divide by that, it just comes down to the bottom line here. Negative 1 minus pi on 4. Now, that looks horrible. Let's have a look at this. So let's just clean this up a little bit. We've got negatives there. So if we take that negative, make that a positive on the top line, and make that positive and that positive. So basically timesing the top line and the bottom line by -1. So then we'll get 3 over 2 bracket 1 plus pi on 4. If I expand that out, I don't know what's best to do here. I'll do a couple of different things. I'll multiply that, so it's 2 plus pi on 2, just multiplying by that 2. I'll put the bottom line over a common denominator, so that'll be 2 on the bottom line. It'll be 4 plus pi. And if you remember, 3 divided by that, there's a couple of ways you can think about it. The 2 is going to shoot to the top. I'll just show you why. So that's 3 over 4 plus pi. Sorry, I've done it wrong. So that's effectively 3 over 1 divided by 4 plus pi over 2. If you're ever getting confused with this thing, that's 3 over 1 times by 2 over 4 plus pi. So that becomes 6 over 4 plus pi. If you're not sort of sure with how these things go, so that 2 will shoot to the top line when you divide by something that has been divided again. So it'll be 6 over 4 plus pi. So finally got to an answer here. It's not as simple. There's a lot of sort of algebra in this particular question, so it's a good one to have a look at it to see some different tricks. So that is my W, right? And so that's my W. Where have I got it? That is my W, isn't it? Where is it? Yep, way back up here. So that is my W. Okay. So W equals 6 over 4 plus pi. That is a 6 over 4. What am I talking about? We need to find out whether the nature of that, is it a maximum or minimum? Okay, so in specialist maths, you could find the second derivative and have a look at that and see whether it's positive or negative. If you're in methods, you need to have a look at a point either side of W to test whether it's maximum or minimum. Okay, I'll just quickly go and see. That's actually a tricky one. Because if you don't have your calculator, that's pretty horrible. So I'm just going to do an approximation here. 6 over 4 plus 3 and a bit. So 6 over 7. So it's going to be sort of like roughly 0.9-ish, right? Okay. Right, 0.9-ish. Right. So let's pick a number that's bigger than that, and we'll just do a sign diagram here. So at let's just say 0.9-ish there. If I choose, let's say 10, something well bigger than W. And if I put that back into my derivative, where was the derivative? So I'm going to say if I put W back into here, there's my derivative there. If I put 10 into that, I'll get 1.5, take away 10, take away something. So it's definitely going to be negative if I go W is equal to 10. So the gradient will be negative there. And if I choose something, let's choose 0. 3 over 2, take away 0, that's definitely going to be positive. So you're going to get a positive gradient here. That means you're going to get a maximum turning point at that particular thing. So yes, that is a maximum turning point. Fantastic. And so we're getting almost to the end here. And so therefore, this 6 over 4 plus 3, that is going to be the maximum. So where the width is equal to 6 plus 4 plus pi, you're going to get a maximum area. All I need to do, though, is just double check. So if I've got this graph and it's maximizing at that particular point, is there another point where it could be higher than that? So you need to sort of check your endpoints. But if I've got a positive maximum point, and this is a quadratic here, okay? So that's a quadratic. Where's my area? That there is a quadratic. And it's an upside down quadratic. We've got this maximum turning point. There's no point that could be higher than that. I can check my endpoints, but I know when W is equal to 0 that the area is going to be equal to 0 because there's nothing exists. And so that definitely is going to be my maximum. Okay, right. So therefore, we're going to get a maximum area when W is equal to 6 over 4 plus pi. What I'll just do, let's just have a look at what that would be if it was a calculator. We'll have a look at that in a second. 6 over 4 plus W. Because what did the question want? I'm just having a look at that. Find if she has what is the maximum area she can create. Okay, so I need to put that back in. I'll just finish this question off with calculator because otherwise it's just going to become horrible. And so you're going to have area is equal to I just realised how gross this question is. I didn't look at this question before, as in like I just sort of just kept doing it on the spot. All of a sudden I can't scroll. So my area is equal to that. I might leave it there. I'm not going to use the calculator. So just to finish this question off, what I would do is I would evaluate what that's equal to, sub that back into the area at the bottom, putting the area into my equation up here, and you'll be able to find the area where the maximum occurs. Hopefully that makes sense. I know I've sort of jibbed it at the end, but you saw how to find the maximum, where to get the W. It also asks for dimensions, so you'd also need to put that W back into the height, which was, where was our height? Back in here. So you would need to evaluate the height is equal to that. You'd need to sub in there. So it's a horrible question. It probably should be done on a CAS calculator to save a bunch of things. I was trying to do it by hand to show you the process, but hope that makes sense. Not the best question in the world to do by hand, but certainly that could be easily done on CAS calculator. Hope that all makes sense. See you in the next video.